Welcome back to the video where we're now going to look at all the instruments. So previously we looked at what are physical quantities and what are some units we use to represent those physical quantities. Now, as you can see, it's a nice collection of equipment where we'll be going through some of these one you will use in lab paper 3. So Miss Lee, what are the equipments we are looking at today?
Well, I think today we're going to start off with the list of instruments from your notes. Okay, so we'll follow this so you kind of like have a checklist of all the common instruments that you may or may not encounter in person or in paper 5. So the first thing we're going to start off is the pretty light and easy measurements for length. Okay, so as usual, we have a meter rule. I'm going to clear the stuff out first. You have a meter rule, but this is a regular old 15 cm rule. In the lab, you will have it at 1 meter long. But let us look at the smallest reading. Miss Ellie, smallest reading can see.
Can. 1 cm chopped up into 10 sections. If you cannot see, you take your own ruler and look lah, okay? You should have this with you.
Yes, and this is so old. It's as old as me. Look at the ruler, look at it. Okay, so this length, the smallest possible reading would be 0. So 1 cm chopped into 10. That means 0.1 cm.
So how would I write a measurement if I measured something?
Let's measure something. Let's measure the width of this box. So if I align here and look here, it looks like 7.7. 7.7. Okay, 7.7. So I can write this as 7.7 cm.
Must include the 0.7, Okay.
Yes, even if it's exactly 7 cm, you should also include the 0.0. So these two must have the same decimal point. Or in other words, same precision. But sometimes when you use the meter rule, macam not enough sensitive, not sensitive enough. So we get to level up. The first level up that we do is this Vernier Calliper. Look at this. Looks like a torture device. So if you've never seen it, yes, it will torture you because you will always forget how to read. So if you've never seen this before, well, this is the first time I have included some pictures in your notes, but this is how it looks like in person. It's made out of metal, okay? And there are two jaws. There's this inner jaw and there's this outer jaw. Not used to bite things, but used to measure diameters of containers like this one. So if let's say I want to measure the outer diameter, which is the lip of the container, I will use the jaw and kiap. And then of course you notice that this container will change size. So ideally when using this, you will try to adjust and push it, and so that it just touches. Okay, then there's a screw up here where my index finger is pointing. You can tighten this, and then you can read the reading. So let's see. What is the smallest reading? How to read this scale, Miss Ellie? Do we have another video on that?
Yep, there's a dedicated one just on how do you read these. Make sure you know how to do that, because in labs, you will be required to use the Vernier Calliper to actually make measurements. And also in theory paper, you have to read it in MCQs.
And for today's video, we just want to know what the smallest reading is to remind ourselves how to write answers, right? So, what is the smallest reading?
It looks like that 0.1 cm on top is kind of chopped into another 10 in the lower part. What's the lower scale called? Vernier scale.
So the top one is the main scale.
Like a ruler?
The bottom one, this one, is a vernier scale.
Okay.
So we chop it into 10 parts.
So can it be 0.01 as the smallest possible?
This 0.1 chopped into 10. Right, this small 0.1 chopped into 10. So 0.01. So your reading for this one could be 7.72 cm. So again, look at the decimal point. We follow the same DP. Finally, the next level up is a micrometer screw gauge. Sorry, typo. Micrometer screw gauge. So
MSG.
it looks like this. Okay, MSG. Oh, by the way, right, this is the inner jaw, outer jaw. This inner jaw is used to measure the inside width. Like this lah. Inside, this is to measure inside. This is to measure outside. Okay. All right. So this is the micrometer. As you can see, it has a very different scale. It has this thing that you can turn. And then you see the gap increasing between the jaws. This side, there's a gap. So I guess this one is to measure really tiny stuff, right? Like for example, maybe you could measure the width, the diameter of this pencil. Wait, turning. So once you turn and tighten between the jaws, you can actually look at this reading here. Okay. So again, there's another dedicated video on how to read this reading. If you don't know, you can go and watch that. But the purpose for this video is we just want to see how to use the instrument for different settings. And in this case, we can look at what the smallest reading is. So if you observe the turning, right? Let's say I turn this. Let's say I start from 0. So you look at the position of this thing on the main scale. It's at 5.2 mm. No, 7 mm. Right? 7 mm. So when I rotate to 50, 30, 35, 40, 45, 50, now it's 5.75. Rotate another complete cycle to another 50. We are now at 8. So this means 0.5 is divided into 50 division. 0.5 over 50. So this one will take 0.5 mm over 50.
0.01.
0.01 mm.
It's the smallest it can measure.
Yes, which is also equal to 0.001 cm. So if you check out the decimal point, each time we level up the instrument, we add another decimal point. For meter rule, it's 1 decimal point in cm. Vernier caliper, 2 decimal point in cm. Micrometer, 3 decimal point in cm. Personally, I find it easier to remember it using the same unit lah. Okay, that's all. I'll highlight that for you. This one, this one, this one. Okay, so that's about measuring lengths, and you may have to be a bit creative. As you do more labs, you will see that there are different ways to measure lengths. We're just here to show you the instrument. Next.
On the list, we have a quantity for pressure, and that is going to be measured with what we call the Bourdon Gauge, or Bourdon Gauge, whichever language you want to pronounce it in. So we don't actually have it with us, but here's a picture of it that you can see. Most commonly, you would see it maybe at some motor petrol stations or some kind of pumps, air pump, air pressure, got tank or something like that. Basically, you'll see a needle, which is over there, in a small round thing. And you see the needle deflect depending on what pressure is inside the tube or a gas supply. Okay,
so this is normally your pressure reading.
And it really depends on which gas pressure Bourdon gauge you are given. So make sure you see between the two small lines, the closest two lines, that would be your smallest reading. So keep an eye out, whatever picture they give you, you can learn to read that. Okay, what next? So other than the gauge, we have top hand balance, spring balance, lever balance. All these are used pretty commonly in labs to measure mass. So you may have seen it before in a physics lab or in a chemistry lab or bio lab whenever you're required to measure things, and it looks like that one, measuring a green liquid right there.
How about baking during MCO?
Baking, if you are the type to use exact amounts to bake, you would probably want to use some of these as well.
Mm-hmm.
Next.
What's next?
We have another one. Force.
Newton.
Want to measure force? There is this very common lab equipment in physics called the Newton meter. It's basically a spring inside, and you stretch the spring. Depending on how much you pull this spring, then you see, it go down. So it's based on Hooke's law. It may not be as accurate as the top end balance, but this is a spring-based way to measure how much force you are exerting on the hook down there, which you cannot see, but there's a hook down there.
Yeah.
Alright.
So those of you who did IG, this is a past year question. And sometimes when I mark your paper 3, you guys like to write force meter. And I go and look at your IG past year paper. Indeed, it was force meter. Please delete this term from your vocab. Thank you.
It's called Newton meter.
Newton feels sad you didn't include his name. Okay, it's the same device. There's a bunch of springs here that they didn't draw. And then you hang your modeling clay. By the way, this is also a method to measure volume. So this thing here is a measuring cylinder. This is a past year question for the IG people, IGCSE people. Okay, so what's the smallest reading for this one?
I think it depends. For Newton meter, you have to see which Newton meter you are given. So best not to memorize it because it might change depending on whichever you are given on a certain day.
Learn to read the instrument. Like for example, this one, what is the smallest reading in between the gaps?
0.2?
That would be your smallest. So the smallest reading, this one would be 0.2. And then like here for this measuring cylinder, this is 1, 2, 3, 4, 5 to 25. So smallest reading is actually 5 ml. Sorry, 5 cm cube. So I see a new instrument, I just stare at it to find out what the smallest reading is. Don't memorize.
Okay, next.
All right, next.
What else is on the list?
Protractor.
Protractor to measure angles. This one is also a very common one in physics. It looks generally like this. Well, you want to read angle, you have to place a protractor against something and you see, maybe Miss Lee can draw an angle somewhere. Just pick an angle and just draw a slanted line.
Okay.
Okay, here we go. So that's the lines. Okay, Miss Lee, how would you read the angle?
Let's say you want to measure the angle of an inclined plane. You notice that the angle we measure from the center here. So your inclined plane, let's say we talk about the green color inclined plane, it should start from here. Okay, so we should start from here. And then if you measure this is your angle, theta. So looking at this, we are measuring from here to here. It looks like 37?
36, 37? Somewhere there.
Somewhere there lah. Roughly next video we'll talk about what to do with the somewhere there but don't know where. It's called uncertainty. Spoiler alert. All right, let's say you want to look at this angle, you will measure. You can measure from both sides, it doesn't matter. But the important thing is please make sure that you start your measurement from here. Whatever thing that you want to measure.
Center of the semicircle.
So here, this one is 65.
We're reading the outer scale, right, for this left side?
Yes. The inner scale is to read the complementary angle here to here. So this inner scale from here to here is your 125. So you add together, 125.
Looks about, 115.
115. Okay, so you're reading from here all the way to here. 115. Okay.
Oh, then the 37 degree on the right side is we read the inner scale.
So this one is from here to here. If let's say you want to read 37, you are reading from here to here. So whether to read inner scale or outer scale, I think different person will print the protractor differently. So it also depends on how the protractor is being labeled. The best thing is use your big brain that you learn in maths and know whether the angle is acute or not. Okay, so if the you can tell like less than 90, this 65. So obviously for 65, we will be reading this scale, less than 90. Because you only got two choice. You either read 100 something or you read 60. So this pink color angle looks like 60 to me.
Okay. What's the smallest we can read again? 1 degree, right?
1 degree. No decimal point. So I don't care even if you think this is perfectly half. You cannot write 65.5. It's wrong. Because the smallest reading is 0.1. Sorry, it's 1 degree. Nearest degree.
So 1 degree, let's write that down in our list here. 1 degree protractor. But also, please double check whatever you are given.
Refer to instrument. Don't forget.
Okay, next one. Ooh, magnetic flux density measured by a current balance or Hall probe. Now this one is a preview of what you'll be seeing in A2. So stay tuned for A2 for more information. But generally, this is how it looks like. You want to measure magnetic field. You stick a interesting looking black color stick inside the magnetic field and you measure it. Something like that. Yeah, but stay tuned. You'll see more about how it works and how to use it in A2. Okay, next, let's go and see what else is on the list. Time. Ooh. Time is measured with a stopwatch or a CRO. Now, we have a stopwatch to show you in a little bit, but let's look at the CRO first. A CRO, we'll learn more about it in another video, especially since we'll be seeing it a lot in waves. This is to measure wavy shape. Generally, a CRO looks like this. It's like a box with many knobs and things, and you will see a pattern on the screen. You see that up and down pattern. Okay, so that's a CRO. Stay tuned also, we'll learn more about a CRO in detail because you need to know how exactly to use it. Here's a stopwatch from our college, MCKL, and it looks generally like this. If you want to use it, you put it in your hand and make sure you see the red button. That's usually going to be your start and stop button. So if you hit the red button, you see the timer begins to run. And you measure whatever you're measuring, oscillation, something falling. And then when you want to stop, you hit the red button to stop. Okay, how do you read this, Miss Lee? What is this number?
Teacher, the 7, 8, what is it?
I don't know. You press start and see, you'll see it's moving very fast, Like you, it's definitely,
More than 60, right? So you don't have some weird idea that this is some weird 60 division as well.
It's even
so if you look
faster.
at second will not exceed 60. So just by your sense of time, you will know that this one is
second.
Okay? And this will never exceed 60. But this one will exceed 60 at certain times.
Millisecond, maybe? Possibly?
It's millisecond. So it's a decimal, add a decimal point for second.
All right, let's go and note down how we can record stopwatch and what is the smallest reading we can get from this stopwatch.
Okay, so as mentioned before, this number at the back is the 1/100 second. This red button is where you press to start and stop. Okay, and this one is the second counter. So this, when you write the reading, right, this will be written, at least this one that is on the notes is written as 27.60 second. And for example, this one on the currently running stopwatch can be written as, let's say for example, I stop now, 1 minute 0300 second. So if you're changing this to seconds in total, this is 63.00 seconds. This stopwatch reading here. Okay, so a second issue about stopwatch is that you can take 1 dp is allowed or 2 dp. Generally, I prefer 1 dp because your human reaction time is 1 decimal point. But Cambridge will also allow 2 decimal point because all your stopwatches are in 2 decimal point.
So those are some examples of the equipment we'll be seeing and using in labs, sometimes in some of your theory papers. But in the theory papers, we're going to focus a little bit more on just how to read certain lengths and, more importantly, how to evaluate the quality of the data that you take. So that's in the theory part. We'll see you in the next section. We will talk about data, uncertainties, precision, and accuracy when you are using tools to measure physical quantities. Okay.
See you in the next one, guys.
Bye-bye.